Greetings everybody. In today's video I'm going to talk about Active Directory authentication and basically why Kerberos was implemented. Precisely, I have to say that this video is going to cover Kerberos in a deep way, but if you ever wanted to understand how Kerberos works in an Active Directory environment, how Kerberos can serve the clients, I guess this is going to be the video for you. But beware, because this video is going to be a bit long and I suggest you to watch it multiple times, and if you fail to understand what's going on in this video, try to read on the subject of Kerberos on other links, and I guess you will be able to understand easily after that. Just try to focus. So stay with me with this video. Okay, let's start our video with a clear example. This slide I'm going to talk about non-Active Directory authentication. Let's say that there is a service on the internet. For example, this is a mailing server like Yahoo, like whatever, like Live, like Outlook, whatever you can call. And in this case, there's a user account who wants to log in to that mailing server from his computer. So the problem is, when the user wants to log in to that mailing system and find the email contents of his email, basically he or she should log in to the mailing service on the internet. So in this case, the user should present a username and a password, but the password and the user is inside the database of that system. In this case, this is a mailing system. So this is easy to understand. The user will need to log in using the username and the password which is residing on the database of the system. In this case, the system, as we said, is the mailing system. So the user sends the authentication to that database, and if the username and password is correct, the user will be able to log in with no problem. But there's a problem. If there are more than one user, there are hundreds and thousands of user accounts. So in that case, the hundreds and thousands of user accounts should be defined in the database of that mailing system. So again, it is not a big deal. Considering a workgroup environment, let's forget about the mailing system of Yahoo and Outlook and things like that. Let's consider a workgroup environment. When you're working in a workgroup environment, there's no Active Directory. So when there's no Active Directory, there is more than one database, which means that all the services that you implement in a workgroup environment will have a database for itself. If you implement, I'm just taking an example. If you implement a mailing system in a workgroup environment, I know this is not possible, but let's say this is an example. If you implement a mailing system in a workgroup environment, user accounts should be defined in the database of that mailing system. All user accounts who works in that workgroup needs to be defined in the database. The problem is when there is more than one service in that workgroup, there should be again the users and passwords should be again defined in the separated database, which means this is another database, the database of the messenger system, for example. And again, if you implement web service in that workgroup environment, again, this is going to be much worse. So this is just a little example of how so many databases and so many user accounts should be defined in order to approve users to log into different systems of a workgroup environment. But this is a workgroup environment. A workgroup is no longer used in organization, and everybody is actually using Active Directory domain services for all the features that it can provide for enterprises. This was the problems of the workgroup environment on basically non-Active Directory authentication. But this is the problems of the workgroup. Let's don't waste our time and let's go for the concept of authentication in Active Directory. This is going to be a little conceptual thing though. Let's say that we have a domain, and in that domain there's a client, and of course there's a mailing server in that domain, and also there are other services in that domain like Skype for Business, like a web service, so many things. Within that domain there's also a server which is called domain controller, or KDC. And also there is a user account who is going to use the client. The good thing in Active Directory and Kerberos and KDC and all these things is that the KDC server which is domain controller in the Active Directory domain, knows all the username and all the passwords. So the passwords is not going to be the clear text, so you can't simply understand what's the password of the user account. They are all hash. I'm going to cover hash and things like that in another video, but just let's say that Active Directory domain controller knows all the password of the user accounts. Not only Active Directory domain controller knows all the password of the user account, it also knows the password of the services. Services are like Exchange, let's consider computer accounts. If you have watched my previous video, I talked about password of the computer accounts. But in this case, Active Directory domain controller knows all the password of the user account and all the password of the computer accounts. So let's consider them as keys, the password. Passwords are just keys, or we can simply say they are long-term keys. So when a user, this one, wants to log in to let's say Exchange server on the right, the user should present authentication request to Active Directory domain controller, or again KDC. The user will simply indicate what service he wants to log in, and within that service he says that who he is. It's not done yet. It's not gonna send this packet to the KDC. Before sending the packet to the KDC or domain controller, the user account encrypt this package with its own password, with its key. Remember that we said every user account has a password, and the password are the keys, or we can say that this is long-term keys. So the user will use its own password in order to encrypt this packet. When the packet is encrypted, the packet will be sent to the domain controller. So how the domain controller will be able to decrypt this packet? Because domain controller knows all the password, it will search to see the packet comes from which user. Once he found the user, will simply use the appropriate key to that user in order to decrypt the packet. So when the packet is decrypted, we can say that this user is the user that is represented in the packet. So it can say that it's okay. So it approves the authentication request. But it is not done. After that, the KDC will copy the packet and will try to encrypt that with a key. But in this time, the key of the requested service is selected. In this case, because the user was trying to access mailing system, the key to the mailing system is selected and then is used in order to encrypt the packet. Once the packet is encrypted, this packet will be sent back to the client. Again, it is not done yet. And the next step, the client will copy the packet and add another packet to the existing packet. The whole packet will be sent to the mailing service. So the packet is in the hand of the mailing servers. So in this case, the mailing service will try to decrypt the purple packet, which is in the left. But again, because the mailing server has its own keys and knows its own keys, it will be able to decrypt the packet. Remember that we said computer accounts do have the password, user accounts also do have the password, and the KDC knows all the passwords. So in this case, mailing servers will actually trying to decrypt the packet, and if it decrypted successfully, it means that the KDC was actually the person who sends the ticket. And within that whole packet, the service actually will find out that the user account is the same. So it will approve the login, and the user will be able to access the content of the email address. So this was the concept of authentication in Active Directory. It was really simple. I tried to explain it in a simple way. But again, within this slide, there are some questions which needs to be answered. The first question will be why event tickets. Remember that we said that when a user wants to access a service, the user will actually create a ticket and will try to encrypt the ticket, the whole packet, with its own key, its own username. And once the packet is encrypted, it is sent to the KDC. The KDC will again try to decrypt the packet, and then after decrypting, the packet, it copy the username or UPN to be more precise, and then will again encrypt it using the key of the mailing service, and once it is encrypted, it is sent back to the client. So all this process for a single ticket of login. So we could simply give this key to this user account, wouldn't we? Yes, it was possible, but there's a problem. If we give this key to this user account, it will bypass the Kerberos, it will bypass the KDC, an involvement of Active Directory domain controller. So when this happens, he has the key to create fake identities. In this case, the user will be able to say, I am Sarah, I am Jack, I am Joe, whatever he wants to be, whoever he wants to be, because he has the key to the mailing service. There is no involvement of Active Directory domain controller, so we should avoid this. And this is the reason why we always involve a third party, a trusted third party, it's better to say, a third party which trusts the user accounts and computer accounts, and the computer accounts and the user accounts trust its back. In this case, this is going to be the domain controller, or KDC. The second question will be, what happens if someone steals the ticket? Is it possible? Yes, it is possible, but it's quite difficult. As we say, that's what happens if someone steals this ticket. So the problem is when the user somehow access to the ticket of another person, he can build the ticket chain. He can say, I am Joe, although he is not Joe. When the user account again access to another ticket of another person, he can simply say, I'm Sarah. He can fake himself, fake identity of himself as the owner of the ticket. So there are some built-in process and procedure in order to make this a bit improbable, but again, it is possible to steal the ticket of someone. Although I'm not going to cover this concept in this video, it is a bit complicated, but it's possible. The third question will be, how many requests? What does it mean? It means that when a user wants to access to a service like mailing servers, he should actually create a request and send the request on the KDC. When there is another request for a web server, the request should be made again on the KDC. When again there is another request, the request should be again made on the KDC. As we can see, the KDC will be under pressure of so many requests for so many services. So Microsoft somehow fixed this. We can say this is a performance issue by introducing two functions of the KDC, which I'm going to cover in the next slide. So this problem of so many requests is somehow handled by using different functions of KDC. So in the next slide I'm going to talk about that, but the fourth question will be, can service verify the owner of the ticket? What does it mean? As we said, that the client will send back the ticket back to the service. So the service will use its own keys in order to decrypt the packet. Once the packet is decrypted, he can say that these two user accounts are the same. But are these two necessarily the same? Isn't it possible for someone to steal the ticket of someone else and fake himself as that person in order to access the content of the email of someone else? Yes, it is possible. So Microsoft again somehow tried to fix this problem. But again, there are methods of using the ticket of someone else, which, as I said, I'm not going to cover in this video because this is going to be a bit complicated video, but this is possible. So Microsoft somehow fixed this problem by the concept of mutual authentication. You will be able to understand more in the next slide. And the last question will be, what about rogue servers? So what is the rogue servers anyway? So let's say when a user, this user precisely, wants to access this mailing server, he should send the request to that mailing server. What happens if somehow there's another server which is a rogue server in our environment. This is not a real server. Someone actually tried to implement a mailing server in our environment in order to redirect the requests from the client to its own server. So what can happen when something like this can happen is that the client will send the request to the fake server and will send the ticket to the fake server. So that server will actually have all the tickets because everybody is actually sending the request to that server. So again, this problem was fixed by the concept of mutual authentication. Things work a little differently in Active Directory. When you power on your system, the first thing you will see in order to log into your computer will be the login screen, or GINA. Within the GINA, you will have to type your domain name, right after that your username, and then the password. These three information are necessary in order to check for the logins and verifying if you're allowed to log in or not. But again, there is one more parameter. Before that Kerberos process your request, 4 information will be sent to Active Directory domain controllers. The first thing, as I said, is the domain name. The second is the username. The third will be the password, and the fourth will be the computer name. When you enter all these information and you hit enter, everything will stop, and the request will be sent to Active Directory domain controller using these 4 parameters. It's better to say that the next 30 minutes, 40 minutes I'm going to explain from now on will just happen right after you hit the enter and you see your profile. Within your environment, it might be a blink of an eye just to see everything on your desktop, but again, in the background, Active Directory processes so many things in order to check for the logins. So from now on, everything will happen right after you hit the enter. Okay, things work a little different in Active Directory, but again with the same principles. So let's consider an example for understanding purposes. Let's say that there's a domain which is called contezo.com. There's a user wants to access a computer which is joined to the domain. The user also knows her password or key or long-term key. When the user wants to log in to that computer, PC1, 4 parameters. Remember that I talked about 4 parameters that are necessary in order to Active Directory authentication. The first one was the username, the second one the computer name, the third one the password, and the fourth one the domain name. Also within Active Directory environment there is a domain controller who serve the clients, Kerberos clients and Kerberos requests. So when the user type the password is gone. When the user type the password, a mathematical function will go through the password and change that clear text password to something called hash. So when hash is obtained, as you can see in the picture, this is a key, the real password is gone. You won't be able to find the password anywhere. You can't find a clear text password anywhere. Well, of course, there are some certain ways to find a password, like a reversible encryption. There are some conditions for that, but again, I'm not going to cover this in this video. But you need to understand that passwords are gone. When user hit the password, it is changed to hash. So the password is gone. You won't be able to find the password. As I said, if you remember, Active Directory domain controller knows all the password. The point is, Active Directory does not know the clear password at all. When we create a user account in our Active Directory environment, we type the password, we confirm the password, and when we hit the next, these password will actually go through the same function, same mathematical function, depending on the encryption type, and basically these clear text password will be changed to hash. So Active Directory database will also know the hash of every user account in Active Directory and hash of every computer account in Active Directory. So within database of Active Directory, which is called NTDS, the user account can be found and the hash corresponding to that user account can be found. So that's why Active Directory knows about every user object and every password. Active Directory never knows the real password. He doesn't know the password. The only time that you type and that you know the password is the time that you create the password, or the time when the user wants to log into computer and type the password. After that, everything is changed. You won't find the password in Active Directory. You won't find the password anywhere. When user wants to log into computer, within the Gina, it will type the password, the username, and the domain name. And as we said, the password will be changed to something called hash. These hash will never send to Active Directory domain controller. This is the point. Why should I send a key, a hash, to Active Directory domain controller? Why? Active Directory domain controller already knows every hash, already knows all the keys. So there's no need to send this key to Active Directory domain controller. So the first thing will happen is that these password will be placed in RAM, in the RAM of the PC1. Within the RAM, there's a private section which is called LSA, and this is a protected section of the RAM, which nobody has access to this part. But again, there are some sort of utilities and tools like dumping memories and things like that, which you can use that in order to fetch the key. But again, the first thing that will happen is that the key will be placed in the RAM. Right after that, the PC1 will try to fire up a packet to domain controller. Within the packet, the first thing that the client will place into the packet will be the username, the user principal name. So in this case, Sarah wants to access PC1, so user principal is Sarah. There are some other additional information that will be placed within the second part of the packet. One of these additional information is the timestamp of the system. The third section of the packet is a little different. PC1 will place the service principal name which was requested by the user. When there is no ticket for client, and this is the very first ticket of the user, Sarah, the very first service principal name will be KERBTGT. It's going to be always like that. The very first packet of the Kerberos for authentication for the client. So these information actually will be placed in a packet, and the client will use the key within the RAM in order to encrypt the second part of the packet. As we said, is a timestamp. Using the key, the second part of the packet will be encrypted and no one has access to it. So, just before sending the packet to the Kerberos, let me say a little about the glossaries that we'll use within this slide. So this part, as we said, is UPN, user principal name. The second part, which is going to be the third packet, the third section of the packet, is KERBTGT. It is called SPN. There are two principal names that always getting used with Active Directory Kerberos. The first thing will be UPN, and the second thing will be SPN. And this part, which is encrypted within the packet, it is called authenticator. The whole packet, all of it, is called KERBAS request, which means that Kerberos Authentication Service request. This is going to be the first ticket of the Kerberos. Once this packet is formed, this packet is sent to the KDC, to Active Directory Domain Controller. Before talking about what will happen when KDC receives the packet, let me say that within KDC or Active Directory Domain Controller, there are two subsystems. The first subsystem is called Authentication Service, or AS. This subsystem is responsible for issuing tickets for very first ticket of the client, for very first ticket of the user. So because Sarah is not logged into the PC yet, for today, the first thing will be generating a ticket. And the very first ticket is called TGT. This TGT will be issued by help of Authentication Service. This is the only time that the client will refer to Authentication Service. I'm going to cover what's the second subsystem of the Kerberos in next slide. But again, just keep that in mind. Authentication Service is the subsystem of a KDC that is responsible for issuing TGT. After that, KDC will try to find out what is inside the packet. So this packet is encrypted within a key, the key of the SARA, in the red part, the second part of the ticket. Because KDC knows all the password within the database, it can simply find out that within NTDS it has all the password and username. So the first thing it does is to find a username within the packet, and inside NTDS it will find the user corresponding to that user. And once the user is found, the key corresponding to that user will be selected. Using the key, the second part of the packet will be decrypted. So this key will be used in order to decrypt the second part of the packet, and the Kerberos will find the timestamp of the system of the client within the packet. If the timestamp is lower than 5 minutes of the Kerberos time, the authentication is performed and the first part of the authentication is approved. Once it is done, you can say that this user is the user that is claiming to be. So Sarah means Sarah. I know it might sound a bit confusing, but again, Kerberos should verify that the user is the person who is claiming to be. Using this method, Kerberos will be able to verify that the Sarah is the Sarah. So after that, the first part of the authentication request is done. And the next section of the authentication service, next part of the authentication request is done within the hands of KDC. The very first thing that KDC will do is to create a key. This key will be used in order to encrypt the future communication between the client and the workstation. So, as we said, the very first thing was create a key. So the KDC will go through a process and create something called a session key. After that, the UPN is taken and the KDC will insert that into a packet. Right after that, all group membership of the client will be retrieved from the Active Directory database, and it will be placed in a packet again. So for example, if Sarah is a member of the domain administrator, that group will be retrieved from the Active Directory database. And of course all other group membership, maybe if Sarah is actually a member of 100 group membership, all those group membership will be retrieved from the database and will be placed in the blue part, as you can see. Next thing, KDC will actually insert the expiry date of the ticket 2 times this time. Yes, one at the top and one at the bottom. This expiry time actually says that this ticket will be valid for how long. For example, in the case of 10 hours, it means that the ticket will be valid for 10 hours. If the 10 hour is passed, the ticket will no longer be valid. And the next part, KDC will copy the session key, which was created at the beginning of this slide, which I talked about, and place a copy of the session key, one at the top and one at the bottom. Right after that, KDC will try to encrypt this whole packet, but using what key? This time the key of the client is not going to be used. KDC will go through the database and find the service principal name, the service principal name of the first authentication request from the client. And what was the service principal name? The service principal name was KERBTGT. KERBTGT is a user. You can simply look it up on your Active Directory database. Since this is a user, it has a password. And when it has a password, it means that it has a long-term key. KDC will try to find the KERBTGT user account and then use the appropriate key in order to encrypt the bottom part of the packet, the blue part, as you can see. So at the blue part, we had group membership, we had expiry date, and we have a copy of the session key. This key will be used in order to encrypt this part. So this part is encrypted and no one can see that. And since the KDC is the only person who has the password of the KERBTGT, no one else can touch it. No one can decrypt that. Okay, the bottom part is done. For the top part, KDC will again try to encrypt the top part, the top section of the packet. But again, this time, because this whole packet will be sent to the workstation, wants to allow Sarah to access to the client, So the KDC will try to find the key for Sarah, and then that key will be used in order to encrypt that part, the yellow part. The yellow part is encrypted using the key of the Sarah, and again, this whole packet will be sent to the client. But before we send this to the client, let's go to the glossary. Remember that I talked about the session key. This is the session key, as we already talked about. This session key will be used for the future communication of the client and the DC. This blue part, as you can see, is the TGT. It's the real TGT. It's the famous TGT that everybody talks about. This is the TGT. And then the whole packet is called Kerberos Authentication Service Reply. Remember that the first part, it was Kerberos Authentication Service Request, but this time, because KDC is actually responding to the request of the client, it is called Kerberos Authentication Service Reply. When the packet is prepared, the KDC will send the packet back to the client, and the client will start processing the packet. The packet, which is called Kerberos Authentication Service Reply. So the very first thing, do you remember that we said that inside the RAM there's a copy of the user long-term key, which is derived from the password of the user? So in this case, the very first thing that the client will do is to get the key from the RAM and will try to decrypt that red part of the Kerberos Authentication Service Reply. So the key is fetched and is used to decrypt the red part. Once the decryption is completed, the client will find out that this packet will only be valid for 10 hours, and also the client will find a copy of the session key. After that, the client will copy a session key to the RAM. Remember that we said that inside the RAM we also have the user password, user key, and also the next thing that the client will do is to copy this blue part. This is, as we said, this is called TGT, and copy that again into the RAM. So the TGT will be placed into RAM for future communication again. After that, the client will try to create another packet. Inside the packet, client will actually place a quite number of information. The very first information will be TGT. So TGT will be copied from the RAM inside the packet. After that, UPN, and after that, expiry time is placed within the ticket, within the packet. And since we cannot simply send the information unencrypted, so this time again, this information will be encrypted. But in this case, session key, which was created in the previous step, will be used in order to encrypt that. So using the session key, UPN and expiry time will be encrypted. After that, the client will insert the service principal name, will request for service principal name. Since Sarah wants to log in to PC1, the service principal name, the very first service principal name to logging for PC1, logging to PC1 is called host. Host service principal name basically means that the user, which in this case is Sarah, wants to log in to PC1. It basically means that the Sarah is pressing Ctrl-Alt-Delete and wants to log in to PC1. He wants to access to PC1 by using local access or remote access or whatever. Once all the information is placed within the ticket, it will be sent to the KDC. But again, this time, authentication service will not be used. Remember that we said there are two subsystems within the KDC, within domain controller. The very first one was authentication service. In this case, we no longer need to talk to authentication service. Remember that I said that authentication service is used only for the very first authentication request. So since we have the TGT, there's no need to talk to authentication service anymore. Instead, we need to talk to the second subsystem of the Kerberos or KDC. This subsystem is called Ticket Granting Service. So let's go for the glossary before sending the ticket back to the KDC. Remember that we said the host is service principal name. So in this case, host is SPN. And then this part, which is encrypted by using the session key, and the session key was retrieved from the process of previous step, this is called authenticator. And of course, you know that the blue part is TGT, and the whole packet which will be sent to ticket granting service is called Kerberos ticket granting service request. So the client will actually send this to the KDC, but not for authentication service. Instead, the packet will be sent to ticket granting service. We no longer need to talk to authentication service anymore. Authentication service is only used for initial authentication, which is going to be getting a valid TGT. So TGS will find the packet at its hands. It is completely encrypted. TGS does not know how to decrypt it unless it starts decrypting the TGT. TGS knows how to decrypt the TGT. Why? Because it has the password of KERB-TGT. So the KERB-TGT key will be used. In this case, this key will be used to decrypt this part, which is called TGT. So this key will decrypt the whole packet, the whole TGT, and TGS will find the information inside the TGT. Once this packet is decrypted, TGS will find information inside the TGT. It finds the membership of the user, it finds the expiry time of the TGT, and of course it finds a copy of the session key. So TGS should do one more thing before sending the next request. And what is that? I'm sure you know that. It is going to decrypt that part. But using what key? The using of session key. The session key in this case will be used to decrypt that part, the yellow part. So the yellow part will be decrypted and TGS will find all the information. It finds the username, it finds the group membership, and it finds all other information. The next step, again, the KDC will fire up a new packet. And inside the packet will place quite a number of information. But before going and talking about the information inside this ticket, let me talk a little about service principal name. Remember that I said host is the service principal name that actually the client will request to have access in order to log into that system. But again, the word host here just for the simplicity reasons, because host is not simply as an SPN. SPN is always a combination of the service, the PC, and the domain. So SPN will always look like something like that. The service name /pc1.contoso.com, which basically means that, for example, if Sarah sent host /pc1.contoso.com to have access, it means that, hey KDC, I want to log in to PC1, which is joined to the domain. SPN will always look like this. This is an SPN. The next thing, KDC will try to create a packet. Within the packet, there are some information, and we cannot simply send information back to the client in clear text in unencrypted way. So KDC this time will try to encrypt the packet by using another key. Remember that we said that database of Active Directory also holds all username and password related to those username. But remember that I said that username are not the only principal that have the password. Computer do have the password. So when the computer do have the password, it means that the computer have the key. In this case, the key of the computer name will be used. But before using the key of the computer, KDC will try to create another session key. This session key again will be shared between the KDC and PC1. So again, once the session key is created, the KDC will try to create a packet. UPN again will be placed within the packet. After that, the membership, the group membership of the client will be placed, and then a copy of the new created session key will be placed. This information will then be encrypted. It has to be encrypted, otherwise it's going to fail. So using the key of the computer account, this part will be encrypted, and no one has access to it unless the KDC and the computer itself. KDC will also copy session key, the new created session key, into the packet, and then since KDC cannot simply again send session key back to the client in a clear text, in a clear format, this newly created session key will be encrypted again. But this time, this key will be encrypted by using the session key which was created in the previous step. And done. It is encrypted. Once it is encrypted, the whole packet will be sent back to the client. This whole packet is called Kerberos Ticket Granting Service Reply. So, Ticket Granting Service Reply will be sent back to the client. And once the client receives the packet, it starts doing the decrypting process. In order to decrypt the process, the first thing that the client do will fetch the key, actually fetch the session key from the RAM, and then start decrypting the decrypting packet. Using that key, the client will be able to decrypt the packet, and once the packet is decrypted, a new session key will be found out. The new session key will be again placed inside the RAM. All the keys, all the session keys, and basically things like that will be placed in RAM. After that, the client will actually prepare the ticket for the service. In this case, the client and the service are the same. So basically the client is sending a request to a service on its own. If it's a bit confusing, consider the scenario where actually a client wants to access another server. In that case, the packet, this packet that we are actually talking about, will be sent over to that server. But in this case, because the client and the service are on the same server, are on the same computer, the same thing applies, the same process will actually done on the same server, on the same client. So after that, the client will start creating the packet. The first thing that the client will do is to implement or insert the user principal name again inside the packet. After that, the expiry time will be inserted inside the packet, and after that, the client name, PC name, will be inserted into the packet. Once the packet is prepared, again this packet should be encrypted and then sent back to the server. Using the key which is inside the RAM, which was actually we talked about, it is called session key. The session key will be used to encrypt this information, and this information will be encrypted. Once the packet is completed, the packet will be sent back to the server or the service, which in this case the server and the client are the same. So again the same process. The service will actually goes through decrypting the whole packet. Because the service does not have the session key yet, it cannot decrypt that gray part. So the very first thing that it should do is to decrypt the blue part, and the blue part will be decrypted using the key of the computer account, using the long-term key of the computer account. Remember that we said this key is actually created when a computer is joined to the domain, and also this key will be changed automatically every 30 days. So every time the client will actually change the key on itself, the KDC will be informed about the new key. Using the key, which is, I'm again repeating that this is the long-term key or the password of PC1, this part will be decrypted. Once the client is decrypted the packet, it will find the session key. The session key will be used now in order to decrypt the gray part. This session key will be again used, and the lower part will be decrypted. Once everything is decrypted, now the service can decide whether to authorize the client, the user, to log into the client or not. From now on, everything is accepted and approved, because the username of Sarah is belong to the person, to the right person. So from now on we can say that the Kerberos did the thing, and the Kerberos actually done everything that it was responsible for. Once everything is approved, the PC1, the client, can decide whether to allow Sarah in order to log into PC or not. If everything goes well, the user Sarah will be able to log in to PC1. And that was the whole process of logging to an Active Directory client. We talked about service principal name a little while ago and the importance of logging in to systems or issuing tickets to client to users. So remember that host, as we already talked about, service principal name host, is not the only service principal name that will be used in order to allow the user to log in to the client. The very first service principal name will be kerb_tgt, and after that host, but also there are other service principal names involved. For example, when a user wants to log in to PC, the PC should also process the group policy objects. And the group policy objects will be always applied during the logon and during the startup of the computer. When a user wants to log in to PC1, so the group policy needs to be updated and refreshed or checked. This will be happen by doing an SMB call to the domain controller, basically on sysvol folder. And since SMB is on another server and it is a dedicated service, again from now on, after issuing the ticket for host, another Kerberos ticket should be issued for allowing the user to connect to CIFS, service principal name, which is basically the service principal name related to shared folders. And these tickets should be issued for the user in order to allow the client to do an SMB call to sysvol folder on domain controller. I couldn't explain again here because it was going to be way more complicated, but if you want to understand what's going on, try to run a Wireshark, a network monitor, to see what's going on when a client wants to log into a DC, and you will basically see all the information inside the packets. Don't confuse things. If you ever try to capture the packet of the client and Kerberos communication, don't be confused and don't be surprised to see the information inside the packet in a clear text. Because basically when you want to capture information, network traffic from communication between a client and a DC, you basically should install network monitor or Wireshark on your DC. And because DC is an endpoint for communication between the client and the DC, most of the information will be visible clearly with no encryption. But again, you will see some encryption and things like that. So if it was a bit confusing, sorry for that. I try to explain all these things in a simplest way. If you want to understand Kerberos in a better way, or basically see what's going on under the hood, you should actually capture a packet and to see what's going on inside the packets, or read more content of Kerberos. And that's it. I hope you enjoyed the video, and I also hope that you have a better understanding of Kerberos and its role within Active Directory authentication. Please subscribe to my videos because I'm going to prepare more content and more videos on some sort of heavy stuffs of Active Directory, and I hope to see you again. Have fun, enjoy around.